Alright, you guys, so we're here once again. I'm here to teach you about, this time, first of all, we're going to be discussing all about the measures of position in quartiles, deciles, and percentiles in ungrouped data, as well as discussing an extra lesson about the measures of position in both quartiles, deciles, and percentiles using grouped data. So we're going to do those two lessons today. So we're gonna start. So the method in finding for the average is the same as finding for the mean of the data. So it basically tells us that the mean is equals to the average of a data set. And you may ask, what is the average? Technically, that is the point in which all of your data corresponds to. So it's technically all of the data, for example, combined into one point. So it can be two points, can be three, combined into just 1 point, for example. It's technically the average, or it's the collective point in which you find all data points together. So in finding for the middle value after arranging the scores in ascending order is median. So example is 1, 2, 3, 4, and 5. So the median after arranging it in ascending order, as you can see, the median is the center. So it's the middle value after arranged. So always remember, in order to find the median, you have to ascend everything and then find the middle number. Right? And the last one is the value that appears the most is the mode. For example, you got 1, 1, 2, and 3. So the mode is 1 since it appears twice. For example, if you got 1, 1, and 2, 2, and 3, so of course your mode is going to be 1 and 2 respectively. But if it's 1, 1, 2, 2, 2, and 3, then 2, 2, 2 is going to be your mode since it has the most value. Alright, so that's the mode. It's the most frequent. Let's explain here. Alright, so now that we have discussed all of that, so the mean, the median, and the mode, these three right here, are called the measures of central tendency. The reason why they're called the measures of central tendency is because they measure a point of a center between a data. Like the average, is a point in the center. Of course, the middle value for the median and the most frequent. It's what you find in the center of a data. So let us recall how to find the median in the set of data. So example here, I'm just going to reiterate this in video form. So what is the median of this set of scores? First, you're gonna have to arrange it all in ascending order. So you got 1, 2, 5, and 6, and then 8, and then 9, and then 12, and then 15. As you can see, it's arranged here. So technically, the median is the middlemost value, so it's going to be 8. So the data usually scores or numbers which represent an individual's characteristic or ability are arranged in ascending order. The data must be written from the smallest value to the greatest value, like ascending F, after which the position is established and the names that depict the order or position are given. We call this type of data as measures of position. So, the measures of position. This is where we're going to discuss all about it. This is the position established by the names that depict the order or position are given. So it's the number that depicts its certain position in a ascending order of a set. So those are what you call the measures of position, because you measure the position of each number that you're finding. Alright? I'm going to teach you as well just a common fact. So I'm going to teach you as well a common fact, of course. In finding the median, you might come across odd numbers. For example, like 5, the n or the total number is 5. For example, you got 1, 2, 3, 4, 5. You got the n of 5, which is there 5 digits. So if it's 5, that means it's odd, which means that it's easy to find the middle number because it's just in the middle. It's divided by 2 equal parts, as you can see. Because there's 2 here, and then here's the median. But what if you have an odd number? Example 4. Your n is 4. So like 1, 2, 3, and 4. So I recommend you to get your calculator in this one. So you got an even number. There's no middle point, considering there's of course there's even numbers in here. So what you're gonna have to do is the number is actually in the exact middle of 2 and 3. Alright, so now that you have this, so it's in the middle, right? So it's going to have to be, in order to solve for the middle number, it's going to have to be 2 plus 3, since of course it's between these two, and you divide it by, of course, or to find the median is divided by 2. Since the reason why it's 2 is because, not because there's two numbers here, because in every number, as long as it is even, it's always 2, since you're technically bisecting it into two equal parts. So 1 is here, and then 2 is here. Technically that's the reason why. So 2 plus 3 is 5 divided by 2 is technically 2.5. So as you can see, the median for this is 2.5. And pretty much that's a trick I'm teaching you guys. So as you know, you've known about the measures of position. It's technically the position of which a data you're finding, a certain point you're finding in a line of data, for example. So the measures of position or relative standing indicate how an item compares with the item in a given collection or dataset. They measure the data's value or relative position within the dataset. These measures include the different factiles. So the different factiles are the percentiles, as you can say, deciles, and the quartiles. So those are the different factiles which you're going to have to relate towards the measure of position. There are 3 types: percentiles, quartiles, and deciles. The median is also considered as a measure of position because you're technically finding a point within a data set. So it's a center. To determine the position or location of a particular data, we divide the set of data into equal parts. So the factiles are numbers that divide and order data into equal parts. So the median divides the data into 2 equal parts, since you're finding the middlemost number. The percentile divides it into 100 parts. Technically that's 100 parts. Considering in a percentage, there's 100 digits. In decile, you get 10 parts, which if you know, so 10 equal parts technically. Wait, so you got 1, 2, 3, okay. So 1, 2, 3, 4, 5, 6, 7, 8. Wait. Okay, so we're missing one. I guess we put it here. So you're dividing it technically into 10 equal parts. So as you know, decile is 10 parts. Well, considering decile is from deci, which means 10. The quartile, of course, is divided into 4 parts, which has here, 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 and also these sides as well. Divided into 4 parts, considering quart means 4, quite literally. So as you can see, quartile is divided into 4 equal parts, so 1, 2, 3, 4, as well as 10 deci, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. With 100, it's hard to count, but you get the point. Alright, so that's how you find the fractals, which are numbers that divide in order set into data in equal parts. So percentile, we'll be discussing first about percentiles. So percentiles are values that divide a set of data into 10 or to 100 equal parts, I mean. So these values are denoted by percentile 1, P1, P2, P3 up to P of 100. So it divides up to 100 equal parts, which is tedious to compute. For example, the value of P50 or percentile 50, or it's also called the median, means that 50% of the data have lower values than P50. So this is what it means. The pth percentile of a given data is a value that's such that P% of the data fall at or below this value. So that's technically the point of which you're trying to find, and that 100 minus P% of the data fall above this value. So technically, what is above that value is more than that percentile, and what is exactly the same or below that value is lower. We're going to do this technically the formula for all of these other formulas later. So one example of the use of percentile is the National Achievement Test, or the NAT score. Suppose your NAT score is the 93rd percentile, or P93. This means that your score is better than 93% of all people who took the same test, and lower than 7% of the same group of people. So that's what it means by measure of position. It relates to other things. If it means by relating to other things, for example, you get the 93%, right? So it relates in a way that in a data set, your score is the same as 93, or the other score is either the same as 93 or it's lower than 93. And there's also 7% who have, higher score than you. But technically it compares your measure of position towards other positions. For example, the 93% fall exactly or under, and then 7% fall above that certain point. That's why it's called relative position, or relative standing, because that point relates to the other parts of the whole table or data. So you took the senior high school entrance exam, you are in the 67th percentile of your batch in the entrance test. Your score in the entrance test is 134 in symbol, so it's equals to your percentile rank in the entrance test is P67, which your score is 134. The explanation is, for A, your standing in the batch is as higher than 67% of the batch. So your standing as high, equal, or higher than 67% of the people that you took the test with. And then for the B, 67% of those who took the test got a score of 34 or below 34, as well as, this is going to be interpreted as 33%. The other 33% of those who took the test got a score above that of 134. So now we're going to be moving in towards the hard part, which is the percentile formula. So this general formula for determining the position of any percentile in the ordered set of data. So the purpose of these formulas, we're going to be discussing percentile formula, quartile formula, as well as a decile formula. So first, we're gonna go through percentile formula. So the formula is for determining the position of any percentile. Note, it's determining the position of any percentile. Alright, it works for percentile. So we all know that the percentile equates to 100 equal parts in a data set. So the formula is going to be, of course, Kn divided by 100 plus 1/2. That is the position of the score of the percentile you're trying to find. So for example, to explain this much better, the height of these 12 students in centimeters were measured as follows. So we got Maria, Nena, Bea, Raymond, Kathy, Juan, Peter, Leah, Paolo, Janet, Carlo, and John. So we got questions here. Who stands in the middle of the line? What height is the median? What the 50th percentile rank? 70% of the students are shorter than what height? And what height is at the 25th percentile rank? So as you know, in order to find A, who stands in the middle of a line, you have to arrange everything in ascending order right here, which is done right here. So since there are 12 students, 2 students are in the middle. So it's Bea and Leah. So 157 and 159. As you can see, the ones who stand in the middle are Bea and Leah. So for B, what height is the median or the 50th percentile rank? So we're going to calculate for it, which is put here. I'm not going to do the whiteboard since it's already put here. So the median height is the average of Bea and Leah's heights, technically. So you're technically finding what is in the exact center, or what height. Keep in mind, what centimeter or what height is the median or the 50th percentile. So as you can see, they keep saying that 50th percentile is equal to the median. That's because it is. Alright? The 50th percentile, or P50, I'll get rid of the TH. So the P50 is the median. Take note of that. We're going to enumerate some stuff. So P50 is the median because 50, of course, is at the middle. If we're talking about the decile of 5 is at the median. because of course from 0 to 10, you might say that it's an even number. It's actually not, because you're considering 0, 1, 2, 3, 4 up until technically 10. So it's actually 11 numbers. So the center number is going to have to be 5, which makes it the median. And lastly, for the quartile, it's quartile 2. You may ask, why is the quartile 2 the median? Well, in a list, if you take a look at this, pretty much this is quartile 0. This is quartile 4, considering you're going to to half this all so into 4 equal parts. So you got 1, 2 there, 4 parts. So this is quartile 1, so the median is quartile 2, and this is quartile 3. That's why it's in the median. So it's in the explanation of all things. Alright, that's why it's the 50th percentile is the median. Okay, so technically, in order to solve the height of the median, you just have to do 157 plus 159 divided by 2. So that's 316 divided by 2 is 158. So the median height is 158. Or we could also find the 50th percentile using this formula right here, the Kn over 100 plus 1/2. So in order to do that, to find the P50, we're gonna have to insert our values. So the K is going to be 50. The K is what we're trying to find, technically. What percentile is we're trying to find. So our N from here, from Kn, is going to have to be 12, considering there are 12 students in our data. Divided by 100, since it's a percentile, alright? It's a percentile. So just add this all with 1/2 or 0.5 in decimal form. This is fraction, this is decimal. You could use either one, it doesn't matter. And so it's still going to be the same. So you get 6.5 or 6.5 height. So considering it's not the same as 158, because this is just looking, because the answer of 6.5, technically you're talking about the place. This is the place of where you're going to find it in ascending order. So in order to find the actual value, you're gonna have to use the linear interpolation. So as you can see, in order to the 6.5 height is equals to the 6th height taken from the 6 plus the 0.5 taken from the 0.5. So you're technically taking from your answer. Then you multiply it by the 7th minus 6th. So you may ask, why is it 7th minus 6th? Because the 7th is you're gonna have to use it, and the 6th is taken from the height here. So you're gonna have to minus the height that you found in your answer with another digit higher than it. So 6, the higher digit is 7, so you're gonna have to minus it. So how to solve for this? So linear interpolation is actually pretty easy. Alright, so you got 6.5 place. If we look back at our list right here, okay, so I'm gonna put this so as you can see, 1, 2, 3, 4, 5, 6. So we're looking for the 6.5th place. This is 7th as well. 6.5th. Since 6.5 is in between these two digits right here, we're going to have to find the middle number. That's why we got the idea for the 6th place. So in order to find 6.5th place, we're gonna have to use the same formula, of course. We get the 6 from here, so 6 from this, you add it by 0.5, we get the 0.5 from this 0.5 right here, and then of course 7th minus the 6th height, which we got the 6th height from here, and then we just add the 6 with plus 1, so that's why it became 7. The reason why also it became 7 in here is because the number that we're trying to find is in between 6 and 7. So that's also the reason why. So as you can see, in order to find this, 6 is 157. We're gonna have to substitute. The 6th value is 157 plus 0.5. Or you can just add it 0.5 and then, so the 7th is 159 minus 157, which equals to 2. 2 times 0.5 is equals to 1. Alright, so 157 that equals to 1. So 157 plus 1, because you know, yeah, it's confusing. So 157 plus 1 is 158, and if you check, 158 centimeters is the median or the 50th percentile right here. If you check, we're right, 158 is the answer indeed. Alright, so 70% of the students are shorter than what height is the next question. The 70th percentile is the height of this position, so we're going to use the same, of course, formula. This time we're finding the 70th percentile, so we're going to use 70 instead of 50. It's the same thing with 12 students divided by 100. It's 100 since it's a percentile, of course, plus a 1/2. So you do all this computation, then it's going to be the 8.9th position. So this time the 8.9. So this is 8, this is 9. So it's in between these two, 160 and 161. So we're going to use linear interpolation, but I'm not gonna illustrate it since it's already here. So 8.9 is equals to, of course, H8, since we got the 8 from the 8.9th position. So the 8th place is 160 plus the 0.9, since we got the 9 from the 0.9 in your answer. Then of course the 9th position minus the 8th position, because it's in between these two right here, between 8 and 9. So you add all of those together. So the height that is in the 8.9th position, which is exactly right here, it's 160.9, which it actually makes sense. Alright, so the D, the final one, is the height at the 25th percentile is found in this position. So the question for D is, what height is at the 25th percentile rank? So we're, instead of 70, we're going to find 25. So it's just substituting work. So instead of 70, we're going to use 25. It's still gonna be 12 since there's 12 students, divided by 100 plus 12, or 1/2, I mean, not 12, or 0.5. It doesn't matter. So as long as you keep doing this, keep adding, multiplying until you get 3.5th place. So as again, we're going to find the height. So the 3.5th place is going to be between 3 and 4, right here. 3 and 4. It's gonna be in between there. We're gonna use linear interpolation as usual. So the 3 is equals to be the 3rd position, because we got it from the 3.5th, plus 0.5 since we got it from the 0.5. Then H9, or the 9th place, minus the H8, since it's between, or actually no, this is wrong, never mind. So this is supposed to be H4 minus H3. So there's a mistake in the module. So it's supposed to be H4 minus H3. So it's supposed to be 152 minus 150, which is put here, a normal grammatical error. But pretty much it's all the same. So we get 151 centimeters, which is in between these two, which is exactly right. Yeah, if you take a look at it, in between 150 and 152 is 151 centimeters. And pretty much yes. So we're gonna use this example right here. Okay, so the following are the weights in kilograms of the 15 students. So I have already done this in advance. I've arranged all of this in my screen. So pretty much it's put here. Alright, here we go. There you go. So I arranged all of this. So technically find the median and the 85th percentile. So the median, just to make it easier, we're going to find the middlemost number. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Since it's an odd number, we're going to find the median pretty easily. It's in the center. So 7 values, so you got 1, 2, 3, 4, 5, 6, 7. So the median is 48. Yeah, it's in the center, so 7 here, there's also 7 here. So 48 is going to be the median. Next, we're going to find the 85th percentile. So pretty much it's the same formula, kn over 100 and plus 1/2. Substitute it. So the k, we're going to find the 85th. So 85 times, if you take a look at the number, there's 15 numbers. It's not 12 considering there's 15 values right here. Because the n is the total numbers of data you have. Divided by 100 since we're finding the 85th percentile plus 1/2 or 0.5. So if you take a look at the calculator, 85 times 15 is 1,275. 1,275. You divide it by 100, it equates to 12.75. So you're gonna add that with 1/2. So 12.75 plus 0.5 or 1/2, you're gonna get the answer of simply 13.25. And pretty much that's it. That's it for percentile. Alright. So next is gonna be the same thing with quartiles. Instead of 100 or 10, we use 4. This time it's the same formula. It's still the same, you know, in order to find the quartile. So in order to find the quartile, it's just same thing. It's kn, but instead of 100, we're using 4 instead. Because it's a quartile, it's not a percentile. It's still the same though. So of course it still follows the same thing. But it's the third quartile. So we're gonna move on. The list shows the bottle of strawberry jam sold in a day by 14 different vendors. What is the third quartile? And what percentage of the distribution fall under the sale? So we're finding the third quartile, which we're going to arrange all of it first. The third quartile, if you take a look, is technically 18, but we're going to use the formula. So this time we're not using 100, alright? This is wrong. So we have to use 100 for this. So K, we're going to find the third quartile. What is the third quartile? So it's gonna be 3 times, as you can see, there's 14 different vendors. So you have to multiply it by 14. Then divide it by 4 plus 0.5 or 1/2. That equates to, so 3 times 14 is equals to 42. 42 divided by 4 is equals to 10.5. 10.5 plus 0.5 is equals to 11. So 11th place is where we're going to find the answer. So considering this is a whole number, it's not a decimal like 11.5 or 11.2. So we can just easily find where the third quartile is. So we got 11th. So hence the third quartile is 18. Because if we count from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the 11th position is the third quartile. So we don't have to solve for linear interpolation in this one. So next is what percentage of the distribution fall under the sale. Well, technically, it's 3/4 or 75%. Therefore, 75% of the sale distribution fall below 18 bottles. As you can see, so we're, yeah. So in order to, so in this data set, I think I have this ready. Yeah, I do. We're gonna do this one. Pretty much. Okay. So we got this. Alright, here we go. So we got this data, which is already ascending order. So find the first quartile. The first quartile, we're gonna have to use the formula kn, of course. This is 4, that's not the right one. Plus 1/2. Pretty much the k, we're going to find the first quartile. So 1. Then there's how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11, and 12. So there's gonna be 12 total numbers. Divide it by 4 plus it by 1/2 or 0.5. So it's gonna be 12 divided by 4, of course, which is 3. So 3 plus or 3 plus 1/2 or 0.5 is equals to, of course, 3 point, oops, oh, it's equal to 3.5. 3.5. 0.5, 3.5. Alright. So, pretty much that is the place of the first quartile. Considering it's a decimal, we're gonna have to use linear interpolation. So once again, it's gonna be the third place plus 0.5, as you know. Since the reason why it's 0.5 is because we this is the third place, we took it from this, and then 0.5 we took it from 0.5, and yeah, pretty much. And you do for the fourth place minus the third place, since it's in between these numbers right here, so 36 and 60. So the third place is meaning 56. So 56 plus 0.5, then 60. 60 minus 56. So it's gonna be 4. So 0.5 times 4 is equals to 2. So 2 plus 56. So this value is 58. So that goes to show that the first quartile is 58. So in between here, technically 58 is the first quartile. So there you go. So that's my last example because the decile is pretty easy. This time we're doing it 10 equal parts. It's the same formula once again, but this time instead of using 100 or instead of using 4, we're going to be using 10. Right? So now, suppose that Andrew's math score is 7th decile or D7. This means that Andrew's score is better than 7 out of every 10 students in his class. So the formula is the same, Kn over 10 this time plus 1/2. Also, you already know this. So the question in this data set right here is, what is the 7th decile? Arrange it in ascending order. So this time we're going to go for the 7th decile. Considering, so K is going to be 7 since we're finding the 7th decile. 14 is, the N is 14 because there's 14 sets right here. There's 14 numbers divided by 10. So that equates to this plus 1/2. That's going to be 10.3 place. Since it's a decimal, we're going to have to use linear interpolation, which, as you know, we take that with the 10th place plus 0.3 because we took it from 10.3. Then 11th place minus 10 because it's between the 10 and 11th right here, somewhere here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's between these two right here. So the answer is 16.6. So that's the 7th decile. Pretty much that's it. So I'm not gonna solve this as you already know what's going to be the answer anyways. It's that easy, and pretty much that's it for measures of position with the ungrouped data. So next is going to be group data this time. As you can see, it's different since of course we're going for group data instead of ungrouped data. Percentile, decile, and quartile. So the percentile is a measure of position. It divides the scale into 100 equal parts, as we've known very recently. Indicates that a certain percent of the data under considerations are at the below and a certain above point. The decile is divided into 10 equal parts, and then quartile divides the number into 4 parts. But technically, these are the steps in solving the measures of position of group data. So technically, what you're gonna have to do is all this. We're gonna make it easy for you. But these are the formulas, right? It's going to be reading all. It's gonna be hard to understand reading all of this. I'm just gonna go through this. So the difference between the grouped and ungrouped data is that, you know, with group data, you are given certain values. For example, like this, you're given 9, 10, and 11. But for group data, there are so much data in the table. For example, like this table right here. There's so much data here that literally they have to segregate it into intervals. So you don't see like 45, 46, 47. That doesn't happen. That's ungrouped data. But this is group data, which means it's going to be an interval of 45 to 49, which makes it harder to solve. but it's pretty easy once you get to know it. Considering there's this much people who did the form, you're gonna have to use the group data form, which requires intervals like 45 to 49, 40 to 44. See the difference? So pretty much, yeah, 44, 45, 46. This is for the ungrouped data. This is for the group data, on the other hand. Considering it uses the dash, or it technically segregates answers into different intervals with the, of course, as I said before, with this dash right here. Alright? Compared to the ungrouped data, which has an exact number. Alright? So, what you're gonna have to do first with this data set, I'm gonna teach you guys along the way. So, study the frequency distribution of the people. So these are the amount of people that filed up for the vaccination form. So you're gonna have to tally how much have done this. So here's a table to make it easy for you. With the cumulative frequency table, find the sum of the frequency. So you're gonna have to tally this all. So for example, you get 42, right? 42, score 42, you're gonna tally it in this interval 40 to 44, 30 from 30 to 34, 15 from 15 to 19, and so on, until you can put all of the frequency and you get the sum, or how much people have filed up for this. If we're going to solve it, 4 plus 8 plus 9 plus 5 plus 4 plus 1 plus 3 plus 1 in the calculator, it's 35. So it's right. So as you can see, the I stands for the class size or the intervals. So the I is 5 because if you count each score, for example, 10 to 14. So 10, 11, 12, 13, and 14. There's 5 numbers, right? So if you count 15 to 19 again, 15 to 19, 15, 16, 17, 18, 19. There's 5 all over again. So these are all the same. These numbers are all the same and have the same interval. So that's how you get it. The I is equals to 15. And the frequency is how much, of course, how much people have filed up for the vaccination form. So step 2, you find the cumulative frequency, or the CF, by adding continuously the frequency starting from the lowest value. So we do this step by step. As you can see, we got the table here, we tallied everything, we got the interval, we got the frequency. Next, we're going to find the cumulative frequency. So how do we do that? We start with the lowest number first. So for example, we start from the lowest score, we gauge it by looking at the scores. The lowest score is 10 to 14, the frequency is 1. So we start with 1 on the cumulative frequency table, or column right here. So as you can see, 1, you're gonna have to add the frequency continuously. That's why it's called cumulative, because it constantly stacks up. So we have the first value, 1 first, which is a given. 1 plus 3 is equals to 4. 4 plus 1 is equals to 5. 5 plus 4 is equals to 9. 9 plus 5 is equals to 14. 14 plus 9 is equals to 23. 23 plus 8 is equals to 31. 31 plus 4 is equals to 35. Up until it goes the same. The final number of the cumulative frequency goes the same with the frequency, the total number of frequency, which is the n right here. So that's how you get the cumulative frequency table, or column. Next step is to find the lower boundary by subtracting 0.5 to the lower value of each interval. For example, I want to explain here. So this is the whole table, right? In order to find the lower boundaries, all you're gonna have to do is look at the lower boundaries. Technically, the lower boundaries of the scores you find is 45. For example, the likes of 45, 40 right here, and 35, for example. Those are the lower boundaries, while 49, 44, and then 39 are the higher boundaries. If you get what I mean. The lower boundaries is what's on the left side, the higher is what's on the right side. So we're going to find the lower boundaries right now. So in order to find it, you're gonna have to use 45, or the lower boundary. 45, you're going to have to minus it by 0.5. So remember, it's minus 0.5 always. If we're finding the lower boundary in a group data, it's always going to be 0.5. No number can go up against this, unless I think if you're going to find the higher boundary, the upper boundary, then for example 45 is the lower boundary, you're going to minus it by 0.5, which makes it 44.5, right? 44.5. You did this. In order to solve for the higher boundary, for example like 49 right here, it's plus 0.5 instead of minus. So it's always going to be the same thing. It's going to be 49.5. So if it's lower boundary, you're going to be subtracting 0.5 always. Always, alright? If it's higher boundary, we're going to add 0.5 always. I think anyways. We haven't gone through higher boundaries yet on this lesson. But pretty much that's how you make the table. If you're given so much data that can't be counted, that is where you use the group data formulas or the table to make it easier for yourself. So the question is, what is the first quartile? Then the second question is, what is the fifth decile? So first we're gonna have to find the first quartile, or the quartile 1. So in order to find the quartile 1, we're going to use as the formulas right here that I've shown you. This time it's different. It's not the same as, you know, as kn over 4, because quartile plus 1/2. No, it's group data, so it's different. So we're going to find the quartile. So qk is equals to bl. So as you know, bl is the lower boundary of that class. You add it, so this is just the formula, so you could all copy this. It's going to be the same thing, but the only difference is, of course, instead of using kn on all over the place, so if it's a percentile you use 100, if it's a decile you use 10, and if you use quartile you use 4. Okay, it's the same. Technically it's the same thing. So this time we're using quartile, so kn4 minus the cfb. So the cfb, so the cf is the cumulative frequency. The b, on the other hand, is the cumulative frequency below that value. So we're going to discuss that later. Divided by fc, which technically fc means the frequency, then times or multiplied by the I, or the interval, and pretty much that's the formula. Alright, we're going down. So to find the first quartile, right? Our k is 1 because we're finding the first quartile. And then our n is 35 since there are 35 people, as you know. So refer to the table, alright? So in order to find the certain place where we can get the first quartile, considering everything is interval based, we're going to have to find which of these rows, not columns, rows. If you take a look at what I'm highlighting, we're going to take a look at the classes. These are called classes. The rows of which that first quartile can be found. So pretty much in order to do that, we're going to be using the formula. Alright, so in order to find the first quartile, first we're going to be using this part, the kn divided by 4. Alright, so basically how you do it is just like this. So kn divided by 4. There's no add 1/2 because that's not included here. But anyway, since we're finding the first quartile, of course the k is going to be 1. Then the n is 35 because there's 35 people, as usual. Then divided by 4. Because 35 divided by 4 is equals to, as you can see, it's going to be 8.75. 8.75. So refer to the table under cumulative frequency. So since your answer is 8.75, we're going to be looking at our table once again. We're going to be looking specifically at our cumulative frequency. Okay? So 8.75. Take a look at that number. Visualize it. 8.75. Where do you think 8.75 stands in each row? We're going to be looking at each row. Okay? So, actually 8.5 can be taken out. So 8.5 is in this row. It's in the 9th. So you might ask, why is it not the 5? Because if you know, if you use cumulative frequency, you know that we add things together to get, of course, cumulative frequency. A stack is up. So this is the class that we're going to use, which has the 9. You may ask, why is it 9? Why is it not 5? Pretty much the answer is, if we start with 5, then if we choose 5, 8.5 can't be found within that 5. So as you can see, in between 5 and 4, if you take a look, 5 and 4. So it ends in 4. So if you count, it ends in 4, and pretty much it starts at 4.1 up to 5. So it ends at 4, example. Then it starts 4.1, 4.2, up until it reaches 5. Okay, you get what I mean? So if we choose 5, we cannot simply, because 5 ends in this place. So we have to choose 9, because 5 starts with 5.1. 5 ends with 5, but then if you take 9, it starts with 5.1, 5.2, up to 6, up to 7, up to 8, until we get 9. So pretty much it's segregated, this place to this place to this place. So as you can see, 8.75 can be found in the 9th place in the cumulative frequency. Based on this diagram, if you know, pretty much that's how it's done. It cannot be 5 because the thing is, it ends with 5 here. So we have to choose 9 because it ends with 9, but 8.75 stays within 9, or between 9 and 5. That's why we're choosing this specific row and not 5, because 8.5 literally can't go in this number, because you literally have 4.1s, 4.5s. 8.5 doesn't exist in the 5th row. Okay, so that's how it's done pretty much. So now that you got your row, we're going to take our answers from this specific answer itself. So now you apply the formula. So as you can see, we take all of our numbers first. So our scores is 25, 28. Our frequency is 4. Our cumulative frequency is CF. Our lower boundary is 24.5, because we took it from 9, of course. That's where we got our 8.5. So that's what you have to go through first. You're gonna have to use this formula first in order to find the value, and then determine from your cumulative frequency on which place you're going to calculate it. So now, pretty much, considering that our as you can see, our class is in 9. So we're going to use the formula right here. So oops, wait. So right here, oops, right here, wait for a moment. So we got, oh no, wait. Okay, here we go. So we're going to use this formula. So since we're finding the quartile, of course, we're going to use QK. So our lower boundary. Okay, so we're gonna solve this. If we take a look at the table, our lower boundary is 24.5. We're just gonna have to copy everything. So this is gonna be 24.5 plus. Alright, so this is where we go with the parentheses. So our Kn is going to be the same as this. Technically, since we're finding the first quartile, it's gonna be 1 times 35 divided by 4, since it's a quartile, and minus by CFB. So CFB, this is our CF. But what is CFB? Well, technically, that number from here, you're technically finding what is below your chosen cumulative frequency, or CF. So what is below 9? Below 9 is 5. That's what CFB means. So we're gonna have to put 5 here, divided by FC. So FC is the frequency on that certain class. So F means frequency, C means class. I think anyways. So technically the frequency on this row that we got is 4. So we divide it by 4. Then close parenthesis times or multiply it by the interval, which is 5 as we discussed long ago. So now if we solve this, of course we're gonna have to put everything here first. So as you know, we already solved this. It equates to, so 1 times 35 divided by 4 is equals to 8.75 minus 5 divided by 4 times 5. So calculator, 8.75 minus 5 is equals to 3.75. So 3.75 divided by 4 is equals times 5. Of course you have to do this. Again, 24.5 to make it easier for you guys. So calculate, use your calculator. 3.75 divided by 4, which is actually the answer is 0.9. So 0.9, 0.94. I'm going to round it up. 0.94 times 5. So we're gonna have to do that. 0.94 times 5 is equals to 4.7. So 4.7 plus 24.5. We're gonna have to add it all together. So 24.5 plus 4.7 is equals to, I'm gonna use the red marker to emphasize, so it's equals to 29.2, and that's the answer. So if we take a look at here, pretty much, so if you round it up, it's actually still right, 29.19 or 29.2, and that's the answer. So pretty much the first quartile is at 29.19 or 29.2. And if we check, alright, so it says here that 29.2 is within this area. If you take a look at the scores, okay, so now if you take a look, does 29.9 go with the scores? It does. It actually does. If you take a look at that pretty carefully. So from the interval from 25 to 29, 29.2 actually makes sense. That's your hint. That's the hint in order for you to find out if your answer is correct or not. Alright, so the next is going to be, I think, easy. I don't think I need to explain this any further. To find the 5th decile. So we used the quartile last time. This time we're going to use and find the 5th decile, or the D5. So since it's a decile, we're going to use kn over 10 instead of kn over 4, of course. Which k, we're going to find the 5th. 5 times 35 is still the same, divided by 10, to get 17.5. As you know in the chart, 17.5, locate it from the cumulative frequency. 17.5 lies in this row right here, in 23. So we're going to use the values in this row. So as you can see, if I can just take a screenshot of this, if I can, alright. Okay, so we're going to solve for B. We got everything. It's in the 23rd row. As you can see, we're right. You apply the formula. So pretty much this time, instead of QK, we're going to use DK since we're going for decile, of course. BL plus KN divided by 10. Since we're using decile, we're using 10 instead of 4 or 100. So it's all going to be the same. Our K is going to be 5 because we're finding the 5th decile. Times the 35, the n, the number of frequency, divided by 10, minus 14. Because, as you can see, below 23 is 14. CFB is 14. BL, of course, is 34.5, as you can see. FC is 9 because it's, as you can see, it's 9 there. And times it by interval 5. If you solve everything, it's equals to 36.44. So if you take a look at this, if you take a look at the scores, from 35 to 39, you'd think that 36.44 is in between those two intervals. Yes, I think it does make sense. Alright, so that's your hint if your answer is actually right or not. and pretty much try this. What is the 80th percentile? So it's gonna be the same thing. This time we're going to be using the formula of kn divided by 100. Since it's percentile, we're going to use 100. So we're gonna find for the 80 times 35 divided by 100. As you can see, it's all gonna be the same. So 80 times 35 is equals to 2,800. 2,800 divided by 100 is equals to 28. So 28 is going to be our value, and if we take a look at the table here, 28. So 28, we have a value of 28, so it's in this row right here. It's in this row. We're gonna find 28. Alright. The 28, we're going to use the same as formula. Same formula, so this time we're going to use pk, since it's a percentile, of course, and vl, plus, of course, this time kn divided by 100, minus the cfb, still the same, but not that same. fc, then times with the interval. So it's equal. The lower boundary, as you can see in the table, is 39.5. Take a look, 39.5 plus, so kn is always going to be the same if they're 80, 35 with 100 minus the CFB, or the cumulative frequency below it, which is 23. As you can see below it, it's 23. So 23. The FC is going to be in here in the same class, so it's going to be 8. As you can see, it's 8 right here. Then with I, it's always going to be 5, since it's all going to be 5 anyways. So we're going to solve for this, okay? So 39.5, so it's going to be 28, because we already got that answered. 28 minus 23 divided by 8, then 5. So 28 minus 23 is equals to 5. I'm sweating bullets. So 5 divided by 8 times 5 plus 39.5. So 5 times, or 5 over 8 times 5 is equals to, plus 3.125, 39.5. So we add that, 39.5 plus 3.125 is equals to, so the answer is 42.625. Or if we round it off, it becomes 42.63. Alright, if you take a look, 42.63, alright, 42.63. If you take a look at the table, you think that 42.63 goes well with the scores? It goes inside of it? Yep, I sure do think so. So yeah, as I've said before many times, that's your hint. And pretty much, yep, these are all going to be the same. It's going to be the same stuff. I don't think I need to discuss any more further. But pretty much 11.5. So your P10 here, so we discovered that this is found within 2. Okay, so another thing that I have to say as well. So if you're using this table, for example, you're finding P10. So P10 is equals to 4. So 4 is found within, of course, in this row right here with the 7. Because that's where it's found. And pretty much you're gonna solve everything. P is equals to percentile, so you're gonna use 100. You get 11.5 as the answer. If you take a look at the score, you think 11.5 goes within 10 to 14? Yes, it does. Pretty much that's it for the whole lesson. So I hope you guys, learned something today. I'm just giving a guide for those who don't understand well, and I hope you do understand this, because I think it's a 1-hour lecture for now. I think I've done this for 1 hour anyways. So yeah, I guess thank you guys for watching, and we'll see you guys on the next tutorial. pretty much have these smudged in their faces for quite literally 1 hour. So I say that's a mission accomplished. Well, you know what they say. If there's an opportunity to reach your goal, there's an opportunity to rickroll.